everyone, I am Abobare Moise and I'll be your chemistry tutor as usual. So today the topic we want to look at here is valency. Valency means the combining power of an element. Valency means the combining power of an element, which means that if you want to combine two or more elements together to form a compound, you will need the knowledge of valency. Now, if you can notice on the board, I have the first 20 elements here, which means that all these elements, I have also written their symbols and their atomic number. This atomic number stands for their proton number, and when they are neutral, it also stands for their electron number. Now, you need the knowledge of valency, and you also will be needing the knowledge of electronic configuration. Now, what do we mean by this? In terms of electronic configuration, there are different ways, but we are going to be talking about the shell notation. Now, the shell notation, I have to talk about it first before we start configuring and before we start combining elements using valency. Okay. According to Hund's rule and according to Nearbo, it stated that all the shell, they starting from K, L, M, N, O, and so on and so forth, they have their maximum number of electrons that they contain. But if you want to know this, you have to remember the formula, which is 2n raised to the power of 2, where this n is what we call the principal quantum number. Now, for each of these shells, all the elements, all the shells, for each of these shells, they have their maximum number of electrons they contain. And this principal quantum number, it varies for them. Now, for the K shell, the principal quantum number value is 1, for L is 2, for M is 3, for N is 4, for O is 5. Now, what do we mean by this, and how does this principal quantum number helps to get the maximum number of electrons that they can contain? For K shell, if you represent N as 1 in this formula, this is how it is going to look like, and mathematically, you are going to solve the bracket first according to board math. So how do you do this? This will now be 2 times, because this is 1 raised to power 2, that's 1 times 1. You have 1, which is 2 times 1, 2. So the maximum number of electrons this can contain is 2. For the L shell, don't forget our principal quantum number is 2. So you have to put 2 inside the bracket in place of N. So all raised to power 2, you now have 2, which is this one. Then this 2 raised to power 2 is 4. 2 times 4 will give you 8. This one, this is 2. The maximum number, the principal quantum number for M shell is 3. And so we have 2 times 3 raised to power 2 is 9. So 2 times 9 will give us 18. Now, what do we mean by this? It means that all this maximum number of electrons they can contain, it is the amount they can contain as long as they are being used. So I will task you, for everybody that is watching me or for the lovers of chemistry who is loving this class, you can as well try the maximum number of electrons this N, O, P, Q, and so on and so forth can contain. So you can try them out considering their principal quantum number. It will be increasing like that, 1, 2, 3, 4, 5. If you want to continue, it will be 6, 7, 8, and so on and so forth like that. So, but for what we have here, I have told you that we will need the knowledge of shell notation for electronic configuration. And the another knowledge that we will be needing is the knowledge of valency. Now, I've told you that what all the atomic number also represent their proton number, and if they are neutral, it also represents their electron number. So, if you want to combine elements together, you need the knowledge of valency. And how do you know the valency? Now, the valency of every of these elements is their outermost electron. What do we call outermost electron? I will give you an example and I will use it to explain. For example, we have hydrogen chloride. Now, hydrogen chloride is the combination of two elements, is a compound which involves the combination of two elements, which are hydrogen and chlorine. Now, hydrogen, we already know that it is the first element of the periodic table, which means that what? The atomic number, the electron number, or the proton number is just 1. So for hydrogen, it is 1. How about for chlorine? For chlorine, it is number 17 in the periodic table. Look at it here. Number 17, which means chlorine is having 17 electrons in its configuration or in its shell. Now, if you want to configure chlorine, how do we do this? Don't forget that we are not emphasizing on hydrogen because it is just having one. So it will be in the first shell. Now for chlorine, the first electrons goes into the first shell, don't forget, and the first shell can only contain 2 electrons, so you put 2 there. So out of 17, we have 15 left mathematically. So what do we do next? We say that the next one we go into the L shell, which is just 8. So out of 17, we have filled in 8, it remains just 7. So what do we do next? What we are going to do next is the fact that we are going to fill in the last 7 there. Now you may be wondering that why didn't I put just the remaining 15 outside here? The reason is that every element, they want to have their last electron to be 8. That's what we call the octet rule. Octet rule. And these elements that they want to look like, they are called the noble gases. All the noble gases, they have 8 or 2 electrons in their outermost shell. Examples are helium, argon, neon, krypton, etc. There are as many as that. So what do we mean? We mean that all these elements, they are noble gases and they have 8 electrons in their outermost shell. Don't forget that octs, from octopus, octagon, they have 8 electrons in their outermost shell. So every element that have 8 electrons in the outermost shell, it means that they are stable and you can really see them going into a reaction. Now, what do we mean and what does this signify and how does this affect the valency? It affects the valency because of the fact that every element that don't have their electrons, their outermost electron in the outermost shell, this is what we call the outermost electron. And they can be filled in what we call the outermost shell. So every element who don't have what we call 8 electrons, they want to look like the noble gases that have 8 electrons or 2 electrons in their outermost shell. They want to be stable too. So in the struggle to want to be stable, they will be looking for electrons either to complete this one to be 8 or to remove from it to complete 8 here. Now, if you look at chlorine now, with 17 electrons, the outermost electron is 7, which means that it is remaining 1 to complete 8. So what do we do? It means that this one is needing 1. That's minus. That is why chlorine is usually minus 1. So that is why it is 1 here. So if you check hydrogen, the valency is 1. Chlorine, the valency is 1 in this case. Because there are some elements, they have variable oxidation state or they have variable valency. So what do we do from here? We are going to now exchange their valency. So the valency of chlorine, which is 1, it comes to H, while the valency of hydrogen, which is 1, will come to Cl. That is why hydrogen chloride is usually HCl. Very simple. Now let's look at another example. Another example that we want to look at will be aluminium chloride. Aluminium chloride. That's aluminium and chlorine. If you want to combine aluminium and chlorine together, don't forget the steps that you are supposed to take first. You need to first look at the first element, which is aluminium here. What position it is? It is in the 13th position. Don't forget their position in the periodic table also signify the fact that it is their proton number and their electron number. So far, they are neutral. So aluminium here is in the 13th position. That means it is having 13 electrons. So what is going to happen after this? This means that aluminium will be configured as this. The first 2 electrons will go into the first shell because that's the maximum it will contain. The other 8 will enter there. I can choose to write the remaining one 11, but it is not proper to write the remaining 11 there. So what we are going to do is that what we are going to fill them 8 by. If they are more than 8, it will be entering 8, 8, 8 because you have to be filling them according to the octet rule. So Out of 13, we have filled in 2 plus 8, that is 10. It remains 3. So look at this. This means that aluminium is having extra 3 electrons in its outermost shell. So this is what we call the valence electron or the valence shell. So this valence electron in the valence shell, it will be used by aluminium to combine with another element to form a compound. So don't forget the example I'm using. Aluminium wants to combine with chlorine to form a compound that is called aluminium chloride. So what do? We have configured this and we know that the valency is this. Don't forget, don't just leave this one, don't touch it. This 2 and 8, this is what we need. So we are going to write Al3. So this is the valency of aluminium. Don't forget that we have done chlorine in my previous example of hydrogen chloride. So for Cl, which is chlorine, is 1. Don't forget what will happen if they want to combine together. What will they exchange? They are going to exchange their valency. So the 3 will come to Cl3. So the 1 will come to Al. You don't need to put the 1 there. So that is why aluminium chloride, whenever you see it, is AlCl3. Now, this is all about valency. You can see how simple it is. And because of how I want to explain every topic in chemistry in a simple manner to you, that is why I have dedicated my time to lecture you on every topic in chemistry. So I am going to give you a task, or you can rather call it a quiz. You can try this out. Water and calcium chloride. So water is gotten from the combination of hydrogen and oxygen in a particular ratio. I want you to do that for me as a quiz. So if you have any question based on this, you can write it in the comment section or you can send me a private message. The other one is calcium chloride. Calcium chloride is gotten when you mix or combine calcium and chlorine together. So please and please, you can help yourself by trying out these 2 quizzes so that you can understand better. Another thing that you need is the knowledge of first 20 elements. You need it very well, especially for those who want to write either JAMB, GCE, NECO, or any other O level that you want to write. Please and please, you can help yourself, and you can also help me making this video by liking it, commenting, and sharing it, especially the sharing part, because it is very important. It might get to a person that needs it more than you. So thank you very much, and I'll see you in my next video.